In the intricate realm where agriculture meets environmental management, pest control emerges as a critical discipline aimed at mitigating the impact of pests on crops, structures, and human health. It is a strategic dance that combines scientific knowledge, technology, and integrated pest management strategies to protect ecosystems, safeguard food production, and ensure the well-being of communities. At its core, pest control is the systematic approach to managing populations of pests, organisms that pose threats to crops, structures, or human health. Pest control professionals, the guardians of this delicate balance, employ a range of techniques to prevent, monitor, and control pest infestations, with the overarching goal of minimizing negative impacts while maximizing ecological and economic sustainability. Integrated pest management, IPM, becomes a central movement in the pest control symphony. IPM is a holistic approach that combines biological, cultural, physical, and chemical control methods to manage pests in an environmentally and economically responsible manner. This integrated strategy aims to disrupt pest life cycles, reduce reliance on chemical pesticides, and promote natural pest predators. Biological control is a nuanced dance in pest control. It involves the introduction or augmentation of natural enemies, such as predators, parasites, or pathogens, to regulate pest populations. This biological ballet leverages the ecological relationships between organisms to maintain a balance that minimizes the need for synthetic pesticides. Chemical control, when necessary, is a carefully orchestrated movement in pest control. Pesticides, including insecticides, herbicides, and fungicides, are used judiciously and in accordance with rigorous safety and environmental standards. Modern pest control emphasizes the use of selective and targeted chemicals to minimize non-target effects and reduce overall environmental impact. Cultural and physical control practices add practical dimensions to the pest control choreography. Crop rotation, sanitation measures, and the use of physical barriers are employed to create unfavorable conditions for pests or to prevent their entry into specific areas. These methods contribute to pest prevention and are often key components of sustainable pest management plans. Monitoring and surveillance are vigilant movements in pest control. Pest control professionals employ various techniques, from trapping and visual surveys to advanced technologies such as remote sensing and sensor networks, to assess pest populations and predict potential outbreaks. Timely and accurate monitoring informs decision-making and allows for proactive pest management interventions. Education and outreach are integral components of the pest control narrative. Pest control professionals collaborate with farmers, communities, and businesses to raise awareness about pest identification, prevention, and management strategies. Empowering stakeholders with knowledge fosters a shared responsibility for pest control and encourages the adoption of sustainable practices. Vector control is a crucial focus within pest control, particularly in the realm of public health. Controlling vectors, organisms that transmit diseases such as mosquitoes, ticks, and flies, is essential for preventing the spread of infectious diseases. Integrated approaches, including the use of insecticides, habitat modification, and public health education, are employed to reduce vector-borne disease risks. Invasive species management is a challenging movement in the pest control symphony. Pest control professionals tackle the threats posed by invasive plants, insects, and other organisms that can disrupt ecosystems and agricultural systems. Strategies for invasive species control often involve a combination of eradication, containment, and mitigation efforts. Technological advancements, including precision agriculture and remote sensing, are shaping the future of pest control. Drones, satellite imagery, and sensor technologies provide new tools for monitoring pest populations, assessing crop health, and implementing targeted interventions. These innovations enhance the precision and efficiency of pest control practices. In essence, pest control is a harmonious blend of science, ecology, and practical strategies, a dance that seeks to strike a delicate balance in the coexistence between humans and the complex web of organisms that share our environment. It is a discipline that evolves in response to ecological dynamics, technological advancements, and the collective commitment to sustainable and effective pest management.